If you're exploring the study of engineers, you may have stumbled across a file called Mechatronic. What is mechatronic engineer and what exactly do a mechatronic engineer do? Well, the Dr. Najev say if you build a mechanical thing that is controlled by electrical components that need software or something similar to make it, then you need a mechatronic. Mechatronics began as A to C kind of engineers for a new technologies age. It has caught on with students who want to learn all of the skill sets required to build a whole machine by themselves or something similar, like work in industries, automotives, or something else. Mechatronics is a crossover from engineers born out of the need for engineers with both electrical and mechanical knowledge. And the early of the 1970s saw a shift toward incorporate electrical power with mechanical factors into our tools and machines. Think of all the items in your home that is moved and are powered by electricity. Your washing machine, your ceiling fan, your food processor, your freezer, or something similar. You use the machine every day, and it's a lot of important. In the 1980s, with the boom in microprocessors, mechatronics grew more popular by the 90s. The field began and incorporate aspects of computer science and programming, creating almost endless possibilities of the useful and mechanic engineer. With all of the crossover knowledge, mechatronic engineers have brought amazing factors into the products they work on. Cars are a great example. Backup cameras, sensors, anti-lock, breakout, require crossover engineers skills to desk and implement and something else.
As we talked before, mechatronics is the intersection of mechanical, electrical, and computer engineering that integrates the principles of mechanics, electronics, and computer to create advanced systems. The term was contained in the 1916, and since then, mechatronics has transformed the world of automation and robotics. This article discussed the evolution of mechatronics from simple mechanical systems to intelligent mechanisms that have become ubiquitous in daily lives. Number 1. Early mechanical system. Mechatronics trace its roots to early mechanical systems such as the steam engine, the spring jenny, and the Jacob loom. These early mechanics were based on simple mechanical principles and required manual operations. They paved the way for the development of more sophisticated mechanics and automation systems. Number 2, the emergence of electronics. The emergence of electronics in the early 20th century paved the way for the development of more complex systems. The invention of the vacuum tube and the transistor led and the creation of electronic circuits that could control mechanical systems. This led the development of electromechanical systems that were more reliable and efficient. Number 3, interaction of computing. The integration of computing in the 70s led the development of the first mechatronic system. The introduction of microprocessor and microcontroller allowed for the creation of complex control systems that could maneuver and control mechanical systems in real time. This marked the beginning of the modern era of mechatronics. Number 4, robotics. The advent of robotics in the 80s marked the significant milestone in the evolution of mechatronics. Robotics is the branch of mechatronics that deals with the design, construction, and operation of robots. Robots are mechatronic systems that can provide tasks autonomously, and they have found widespread application in manufacturing, healthcare, and the military.
Smart systems. When the millennium had turned, the birth of intelligent systems had already become. These systems used to use only senses and actors. Now, thanks to this, has intelligent control algorithms to sense environment, to make decisions based that information. We hope that in the future it will be controlling complete process at home and transportation and healthcare. The Internet of Things is a network interconnected devices that can communicate and exchange data. It helped revolution mechatronics when intelligent systems began communicate with each other and the internet. Maybe in the future the cities will be working like smart factories. Artificial intelligence. It's the branch of computer science that deals with the creation of intelligence machine that can perform tasks that require human like intelligence. Before, it used to be a dream. It revolutionized mechatronics because it had allowed machines to learn from their environment and make decisions based on that knowledge. The cyber physical systems are mechatronic systems that integrate physical and computational elements. The CPS are intelligent systems that can interact with the physical world in real time. The future of mechatronics looks promising with the continued integration of AI, IoT, and CPS. In 10 years, the intelligent machine will be becoming more ubiquitous and, and in our daily lives. It will making our life easier, and this save us more time to enjoy it in other things. In the future, there will be from autonomous vehicles to intelligent factories. The mechatronics will continue to drive innovation and shape the future of technology. In conclusion, the evolution of mechatronics has transformed the world of automation and robotics from simple mechanical systems to highly advanced intelligent machines. Mechatronics has integrated the the principles of mechanic, electronics, and computing to create complex systems that can sense, process, and actuate the physical world. The continuum of integration of, of AI, IoT, and CPS will pave the way for a future for intelligent machines are, u- are ubiquitous, transforming the way your life, work, and interact with the world.
Yep, I've actually worked a couple of years with that, and yeah, well, it's a very very important tool in many contexts in engineering, not only in computation engineering, but also all of the variety of applications that you may want to go for. Well, mechatronics is a combination of mechanical and electrical engineering, focused on the design and the construction of electromechanical systems that respond to a wide variety of problems in different contexts, not only directly in mechanical engineering, as can be, for example, manufacturing or fluid mechanics or thermal engineering, but also in the part of automatization, for example, and robotics. So yeah, it's a proper balance of all of these subtopics, I'll say. And yeah, that's what it comes to my mind when somebody asks me about what mechatronics is. Well, I think it has to do with the amount of processes and the amount of things that you can convert into a automatic task, for example. Again, robotics and all the every device that you can think of can be somehow turned into a automatic system with the help of proper programming and mechanical design. So I think that in the future we will have, or we will see, I think we are seeing it already, that many tasks that we humans perform can be done more easily and in a more rapid pace if we use control machines, and also for not only for everyday tasks, but also if you want to go for something which is dangerous for humans, or an environment that is not appropriate for humans, we can also rely on machines that can help us go get what we want from many processes. So I think that's the reason people say that everything is turning or is pointing towards a trend in which you can find many things already done by machines, not anymore by humans as it was in the past. So I think that's the global trend nowadays. So I think that's the reason people say that mechatronics is the way to go.
Está bien largo.